Any doubt from the mid-sem? Just let me share my screen. What we have discussed in the last class, do you remember? Yes, am I audible?
Yes, sir, you are audible, sir.
Yes, sir.
Okay. Any doubt from mid-sem?
No, sir.
The solution, I'll provide the solution to your mail. Check it. Still, if you have doubt, then you can discuss. So
Okay, sir.
before mid-sem, what we have discussed, you remember that? Input output characteristic of CB configuration, common base configuration we have discussed. Okay. So today we'll discuss C configuration characteristic. Common emitter configuration characteristic. So for that, first we'll make the circuit diagram. So common emitter characteristic means first you have to draw the transistor so that the emitter terminal is at bottom, and I'm taking PNP transistor. Okay. Then you connect one resistor here across the base, and base emitter junction should be what type of biased? Base emitter junction forward bias or reverse bias? For normal operation of transistor, base emitter junction should be forward biased and collector emitter junction should be base collector junction should be reverse biased. I told you. Okay. So this is P, this is N, this is P. So N will be connected to negative, P will be connected to positive, so that this junction will be forward biased. Okay. This is your emitter base voltage. This is RB. This is PBP. Okay. Current is outgoing. Here current is incoming. Here current is outgoing. So base emitter junction is forward biased. Now we'll do collector base junction. So if you remember the common base characteristic, you see here, this is P, this is base. Okay, emitter and base. Emitter is connected to positive, base is connected to negative. This is forward biased. Output side, base collector junction. So collector is P type. So we have to reverse bias, means P type will be connected to negative, and base, which is N type, is connected to positive. So this junction is reverse biased, and this is forward biased. But here in common emitter configuration, we are not getting direct connection between collector and base. You see, this is my emitter, this is collector, this is base. So there is no direct connection between base and collector. So we have to take the reference. Okay. So what I'll do, okay. So if I connect P side to positive and N side to negative, then what will happen? You consider only collector and base. So collector is P type material which is connected to positive voltage, and base is N type material which is connected to negative. Now tell me, base collector junction is forward biased or reverse biased? Base is N-type connected to negative, collector is P-type connected to positive. So this junction is forward biased or reverse biased?
Reverse biased.
Reverse biased. So this is a diode, this is P, this is N. Okay, so P is connected to positive and N is connected to negative. So this is forward biased or reverse biased? This junction is forward biased or reverse biased?
So forward biased.
Diode junction is forward biased. Okay, so we have taken like this, means it should forward biased. But what is my requirement? My requirement to bias this junction as reverse biased. Okay, so whatever assumption I have taken, that is actually wrong. So what I'll do reverse connection. Okay, so I'll erase this one and connect opposite to that. Okay, now this is negative, this is positive. So how will think this one? Now suppose I'll connect here -5 and here -7. Okay. Now -5 and -7, which is greater?
-5.
-5 and -7 is smaller than -5. So if I connect like this junction is forward biased or reverse biased? This is the first case, and second case -7 volt, -5 volt. Tell me, first case and second case, the junction diode is forward biased or reverse biased? Or which case is forward biased, which case reverse biased? Not getting confused? If you remember, during the diode concept, I have told you this is P, this is N. Suppose I'll connect here 3 volt and 1 volt, then this junction is forward biased or reverse biased? Tell me. P side is connected to 3 volt, N side is connected to 1 volt. Diode is forward biased or reverse biased?
Forward.
Forward biased. 4 volt -1 volt. Then
Forward.
forward. So similarly, you analyze out of -5, -7. If I connect P side -5 and N side -7, then this would be forward biased or reverse biased?
Reverse.
-7, -5.
Forward bias.
So though here both are positive, okay, we can say compared to 1 volt plus 3 volt is higher. So P is connected to higher potential, N is connected to lower potential. That's why the junction is forward biased. So here also you can think like that, though both are negative, but depend upon which one is positive and which one is negative, comparative sense, we can say the junction is forward bias or reverse bias. Okay, so here if you understand this concept, then P is connected to negative, here N is connected to also negative, like this. Okay, like this concept, both are negative, but we have to choose proper voltage so that P side will be less potential and N side should be high potential, so that N will be connected to positive as such and P is connected to less positive or less negative. Okay, so that the junction base and collector junction should be reverse biased. Okay, here we have not given any value, actual value, but for understanding, if you understand this value, then we can put the value while considering the circuit connection or calculation. Okay, so this is the concept. That's why both the junctions are connected to negative potential. And I'll name is this is connected to collector side, so you can name it as VCC. Okay, so once you connect the circuit, then we can go for characteristic. So here you can give the name as RC and VCC. So this is the circuit diagram. Any doubt regarding the drawing of circuit or how to draw the circuit diagram? First, take the transistor, orient the transistor such that emitter will be at bottom side, then connect the resistor and connect the voltage. I will connect the voltage, base emitter should be forward biased. So according to that, you give the voltage, and base collector should be reverse biased. According to that, you have to connect the voltage at the collector side. Okay. Now, input characteristic means input voltage versus input current or different output voltage. Okay, so what is my output voltage? The voltage between these two terminals. So this is V. See, emitter is positive, collector is negative. So V EC. Okay, here VEB and VEC. So when I plot the input characteristic, x-axis and y-axis, first I have to label it. So what is my x-axis? Input voltage. So input voltage is VEB. Okay, versus input current IB in micro ampere. VEB versus IB. IB is outgoing. For PNP transistor, for NPN transistor, it will be incoming. So you just consider about the magnitude. This direction is depend upon the type of transistor. Okay. So though the direction is outside, but it is incoming current. Now, what I will do for particular VEC, let us take 2 volt, then I'll increase to 4 volt, then 6 volt. I want to plot the graph. So you see the emitter base junction is like a diode junction or not? Emitter base junction, I can connect because this is N-type material. So this is like N and this is like P. This is like PN junction, and it is connected to negative, it is connected to positive. So this junction is forward biased. So the characteristic will be same as PN junction characteristic. When VEB increases 0 to, let us take 0.2, 0.4, 0.6, 0.8, 1, 2, like that, it will increase. So what happens? Slowly the current will increase like this. Okay, because this is like diode junction. So for VEC, 2 volt, I'm getting this type of characteristic. Up to if it is silicon transistor, then up to 0.7, very small current. Then after that, current is increases exponentially. Clear? Now, if I change VC to 4 volt, okay, VEC to 4 volt, then what will happen? I'll change the VEC to 4 volt, again start my operation or increase the voltage from 0 to positive voltage in positive direction for VEB, and I'll observe the base current. So for that, what I'll do, I want to know the relation between VEC and junction voltage. Okay, so for that, what I am taking here, you just see. Let me a little bit squeeze it. Okay, so I'm taking the transistor out of this circuit and making it here. Okay, so this is your P, this is your N, this is your P, and this is your emitter, base, and collector. What I have taken, base emitter junction should be forward biased, so N is connected to negative, P is connected to positive. So voltage between these two is VEB. Same thing I have written, again I am repeating here. Collector base junction is reverse biased, so that means P is connected to negative, N is connected to positive, then it is reverse biased. So what is the voltage? Base is positive, collector is negative with respect to base, so this is VBC. Similarly, collector is negative, emitter is positive, so this is your VEC. Now apply KVL. Okay, like this you apply KVL. What I'll get? Minus to plus VEC, plus to minus VEB, then plus to minus VBC equals to 0. Okay, so VBC equals to what? VEC minus VEB. Okay, so if I multiply with negative sign to all the terms, then what will get? We know VBC equals to VB minus VC. Similarly, VCB equals to VC minus VB. That means VBC equals to minus of VCB. Okay, so if I multiply negative sign with all the terms, then I'll get VCB equals to VCE minus VBE. Okay, so you can take this one or this one, depend upon your condition. Suppose you will take here, instead of VEC, you can take VCE. Instead of here VEB, you can take VBE. So that's why these two equations are useful. Okay, now what I am doing here, for particular VEB, suppose I will fix this VEB. I want to find the current at 0.8 volt VEB. That means I am fixing this VEB. So this is fixed. Okay, then what I have done, VEC 2 volt to 4 volt. That means VEC is increases. So VEC increases means in this equation tell me VBC will increase or not? VBC equals to VEC minus VEB. VEB is constant, and when I increase VEC, VBC will increase or decrease or remain constant? This equation, to take this equation, VEB is constant. If I increase VEC, then VBC will increase or decrease or constant? तो क्या होगा? ये इक्वेशन तुम्हें आता नहीं है, सिंपल कंसेप्ट. लेफ्ट साइड में इंक्रीज होगा तो राइट साइड में इंक्रीज होगा तो लेफ्ट साइड में इंक्रीज होगा कि डिक्रीज होगा? तो मेंटेन इक्वल ये सब कैसे समझोगे? VBC equals to VEC minus VEB. Let us take this is fixed to 2 volt. Okay, or you take a simple example. Two volt minus VEC equals to VBC. Now if I take this value as 5, so 5 minus 2 is 3 volt, right? Now I'll change this one to 7 volt. Then this should be what?
So 5.
This should be 5. So what happened here? 7 and 5. It is increases. Then it has increased or decreased or remain constant?
So increased.
Increase.
So if you fix this one, then whatever increment here, that should reflect here, right? So increasing in VEC should increase the base to collector voltage. Here also same thing. If I take instead of VEB, I can also take VBE. So if it is fixed and I'll increase VCE, then VCB will increase to maintain equal both sides. Very simple concept. You have studied in 10th standard. Now, what we have understood here, once the VEC or the emitter collector voltage increases, then that is increasing your base to collector voltage. Okay, increase in emitter to collector voltage, increase the collector to base voltage. So collector base voltage is reverse biased or forward biased? Collector base voltage is reverse biased. So more reverse bias means what will happen? Explained here. VCB increases, so base width modulation happens. So base width modulation happens means the effective base width will decrease. So effective base width decrease means the base current will decrease or increase? Base width decreases means effective base width decreases means the base current will increase or decrease or remain constant? 2 दिन पहले एग्जाम दिए थे, क्या लिखे हो पता नहीं, क्या पढ़े हो पता नहीं, हाँ? Okay. Now I am increasing this one. Earlier the base width is here to here. Now increasing this voltage, the depletion region increases. Now base width is this much. So effective base width decreases. So what happened to the base current? Decrease or increase or remain constant? Initially from here to here I am finding carriers. Now I am finding carriers from here to here. So here the current will decrease or increase or remain constant? I am finding earlier the carriers within this region. Now I am finding electrons within this region. So where I'll find more carriers, earlier or now?
Earlier.
So current will now decrease or increase?
Increase.
Increase.
No, decrease.
So IB current, because the area decreases, then definitely the carriers present here will decrease. So the current IB will decrease. That's what I have discussed in base width modulation. Here everything is written: actual width, effective width, base width modulation. I have drawn here. Will not study, then how can someone will help? So ultimately, what do we know? When we increase VEC for particular VEB, the IB will decrease. So this is my IB axis. So now current will decrease means slope will decrease. So I'll get this graph for VEC 4 volt. Similarly, if I increase VEC for 6 volt, then the graph will shift like this. So VEC 6 volt. Okay. So if I take the current, you see, for same 0.8 volt, see, this is IB for or IB1, IB2, IB3. So IB1 is more than IB2, more than IB3, right? So IB1 to IB3, it is decreasing when we are increasing VEC 2 to 4 to 6 volt. So this is your input characteristic of common emitter configuration. Even you can take the current at this point also, 1 volt, same thing. You see, for when VEC is 2 volt, I'm getting more current. When VEC is 4 volt, I'm getting less current, right? And when VEC is 6 volt, I'm getting still less current. So IB is decreasing or increasing VEC or VC. Okay, so this is the input characteristic. Now we'll go for output characteristic. So output characteristic is same as CV configuration, but the difference is here the x-axis and y-axis. Okay, can you tell me what is my output current and what is my output voltage? X-axis, what I will take in x-axis, what I will take in y-axis for output characteristic. Output characteristic means what? Output voltage versus output current for different input current. I think you have done in, this one in lab. Is it completed or not? Transistor characteristic.
So half done.
Have done. So what you have done? Input or output?
So there are two experiments regarding transistor. One we have done.
No. Two experiment regarding means I don't understand. Input, output characteristic. So if you have done half part means what you have done? Input characteristic you have done or output characteristic you have done?
We have done both, sir.
You have done both.
Yes, sir.
Yes, sir. This graph we have done.
So IB current is decreasing. After finishing of this class, you check it whether it is we are getting this type of graph or not. Okay. And output characteristic means output current versus output voltage. So output current is your IC. You see, this is your output current and output voltage is your VEC. So output current and output voltage for different input current. So what is my input current? IB is my input current. Okay. So what I'll do, first I will fix the IB, then I'll increase the VEC from 0 to higher voltage and observe my IC. Okay. Now, what is the equation for common emitter configuration? IC equals to, what is the equation, base equation for common emitter? Tell me. कुछ याद नहीं रखोगे तो कैसे पढ़ाई करोगे? हाँ, IC equals to beta IB plus leakage current. We have derived all these equations. Now, if IB is 0, what I'll get? IC equals to ICEO. That is your leakage current. So when I increase the VEC from 0 to just take 2, 4, 2, 4, 6, 8, 10, 12 like that, then initially current is very small. Okay. When IB equals to 0 microampere, I am getting only leakage current, which is very small. Okay. Now, when I increase this IB from 0 to 10 microampere, then current will increase. Okay. So current will increase means it will increase like this. This is for IB 10 microampere. Then I'll set IB to 20 microampere. So I'll start from 0 and increase the voltage. So current will increase like this. Have you got this type of graph?
Yes, sir.
So for IB0, this is your leakage current, which is very small, and after that it will increase. So let me take the numbers here. Let us take 2, then 4, 6, 8, 10, 12, 14, like that, milliampere current, and here the voltage. So this region is called as cutoff region, like in common base configuration, because we are getting very small current, that is ICO. Okay, and this region is called as active region, and this region is called as saturation region. And if you extend the voltage here, then we'll go for breakdown region. Generally we avoid this one. So like common base configuration, here also 4 or 5 regions are there. So out of that, 3 regions are important. And saturation, I told you, when I extend this one, then it will meet to a point. So in common base, it is not meeting in single point because the voltage is you see, can you differentiate the difference? Last class, you see this figure in active region and this figure in active region. What is the difference? Can you mark it and tell me? Any graphical difference? Again check the characteristic here and the characteristic here. Any difference to mark? Mark the slope. Common base configuration and common emitter configuration, slope is different or not? In common base, the lines are parallel to x-axis. You see, these lines are parallel to x-axis, but here it is not parallel, slope is there. Do you mark the difference now? अरे हाँ कि नहीं?
Yes.
Why you are not active in the class? Because whenever I am asking, you are not replying.
Sir, I am
Not-
having a network issue, sir. My Wi-Fi is not working.
One is having issue, but all 80-90 students are there. I'm not asking difficult question. Whatever I'm discussing, I'm just showing 2 figures and asking what is the difference. If you not tell, then what I think. So this slope is increasing. Okay. So compared to common base, common emitter have slope, and that indicates the current increases when VEC is increases. Okay. So IC current increases means what happens there? This region is base width modulation. Okay. So when VEC increases, just last input characteristic we have seen, when VEC increases, then that increases VBC or VCB. So collector base voltage or reverse bias increases, that means the base current is decreasing. Base current is decreasing means that will ultimately increase the IC, because I equals to IC plus IB. IB is decreasing means that will, whatever amount is decreasing, that is added into IC. So IC current is increases. So the slope is very slow. It is not like steep slope we'll get, but that current is captured by this IC. Okay, that's why the current is increasing when I am increasing VEC. So I am moving VEC in this region 0 to higher and higher voltage. So IC current will increase. Okay. So this is all about the output characteristic and input characteristic for common emitter configuration. Common collector configuration almost same of this one. If you consider the common collector configuration, let us first draw the circuit diagram. So first orient the transistor such that the collector terminal at bottom side. So I am taking, this is my emitter, so that bottom side will be collector. So this is your P, N, P is your emitter, base and collector. So base and collector should be reverse biased. So I'll connect here, N is connected to positive. So this is your RB, this is your VB. And this voltage between base and collector is VBC. Similarly, here emitter base junction is not directly connected. What I'll do, I'll connect resistor and connect the positive potential and negative potential. So like last circuit, you have to connect a relative polarity of voltage so that emitter will be higher potential, base will be lower potential. Suppose I'll connect here 7 volt, I should connect here 5 volts, so P will be more positive compared to N, so that this junction will be forward biased. Okay. So without voltage, I am giving here name. So this is VCC. So what is the voltage between these two terminal? VEC. Okay. And what is the current direction? IE incoming. So IB outgoing, IC outgoing. Now for output characteristic, what I will take? Output current versus output voltage. So my output current is IE, output voltage is VEC. For different input current IB, now you compare with common emitter configuration. What is my output current? IC, output voltage VEC, and input current is IB. So what are the parameters are same? Tell me. Tell me here. Output current in common emitter IC, output voltage VEC for different IB. For common collector, output current IE, voltage VEC, input current is IB. What are the same thing? This also you don't know. Simple comparison between two notations. Output voltage VEC versus output current IE. So what is the change here for different IB? So only difference is this IE here and here IC, and we know IC is almost equal to IE. So that's why the characteristic also same as common emitter configuration. So if I take IB 0, 10, 20, 30, 40, then you will get almost same type of characteristic what we are getting for common emitter configuration. Only difference is instead of IC it will be IE. Okay, so this is your IB 0, 10, 20, 30, 40, complete. Same active region, cutoff region, saturation region, you can mark it because the output current instead of IC it will be IE. So IC is almost IE, so characteristic also same. Now when we go for input characteristic, input voltage is VBC and input current is IB. Okay, so for different output voltage, that means for different VEC, I'll try to vary my VBC and try to find the base current IB. So let us fix VEC 2 volt. Okay, so once I fix the VEC for 2 volt and increasing the VBC and observe the IB, then again I'll change VEC to 4 volt, then increase the VBC from 0 to positive voltage, higher voltage, and measure the IB current. So what I'll do, I need to find out what is the relationship between VEC and IB, because I want to draw the IB versus this VEC. And you know, earlier for common base configuration and common emitter configuration, what we have done for input characteristic, you just see here. See, input side we are getting PN junction diode. For common base also same thing we are getting. See, this is P, this is N, so this is like a diode and this junction is forward biased. So in both the cases, common base and common emitter, we are getting forward biased junction. So the variation of voltage and current like PN junction diode. But in this case, the base collector junction is reverse biased. Okay, base collector junction is reverse biased. It is not observe the forward characteristic or diode characteristics. So I'll take this transistor out of this circuit to know what is the relation between these parameters. Right? So this is your emitter, collector, base, and base collector junction is reverse biased. So what is my PNP? So N is connected to positive, P is connected to negative. So this is your VBC. Emitter, base, forward biased. So emitter is connected to positive, base is connected to negative. So VEB. Okay. Then this is positive, collector is negative. So this is your VEC. Now, like last diagram, we apply KVL here. What will get? Plus to minus, minus VEC, then minus to plus, plus VBC, then minus to plus, plus VEB. Okay, applying KVL, we are getting this equation. Now, VEC equals to VBC plus VEB. Okay. Now I have fixed this VEC to 2 volt. So this is fixed. Okay. And I'm increasing VBC. That means 0 to, let us take 1, 2, 3, 4, 5, 6. VBC is increasing. This is constant. Then VEB will increase or decrease or remain constant, tell me. left hand side is fixed, right hand side one parameter is increasing, so other parameter will increase or decrease or remain constant. To maintain the equation validate. Left hand side is fixed, it is 2 volt. Now VBC is increasing means this should decrease or increase or remain constant?
Decrease.
Decrease. So base emitter voltage is decreasing means the junction is less forward biased. Emitter base junction is actually forward biased. It is decreasing means it is less forward biased. So less forward bias means IB current will decrease or increase. PN junction characteristic. What we are taking? Current voltage is increasing, current is increasing. Now if I go reverse way, voltage decreasing, then current will
Decreasing.
decreases. So here same thing I am doing. When I am increasing VBC by fixing VEC, that means ultimately VB or forward bias junction voltage is decreasing. That means IB current will decrease. So this decrement I can represent like this. Okay, that means if I take one potential 1 volt and 2 volt, and what is my current? So at 1 volt I am getting, let us say, 5 microampere. Here I'll get 2 microampere. So IB current is decreasing. Okay. Now if I increase VEC to 4 volt, then the graph will shift right hand side. Okay, because this will increase from 2 volt to 4 volt means the entire thing will shift right side. So I can write VEC 2 volt, here VEC 4 volt, like that it will also change. So this is the input characteristic of common collector configuration. Okay, so input characteristic of common collector configuration. Output current, output configuration for common collector is same as output configuration for common emitter configuration, and input characteristic of common emitter and common base are almost same with only minor difference. Okay, so out of these 3 characteristic, any one will be coming in the exam. The transistor circuit diagram as well as input and output characteristic. So you have to explain the proper reason why the current is increasing, decreasing, and if it is output characteristic, different regions like active region, cutoff region, saturation region, everything. Okay. So we'll stop it today. Next class we'll go for biasing.
Okay, sir.
You guys are actually not responding all. Means I think you are not studying properly. Don't leave the meeting. Let me take the attendance. Many of the students are not responding. Only 1 or 2 are responding. That too very late.